to the Autodesk Speaker Series room. So I was just talking to my colleagues, and I think I have the worst time slot. It's the first morning slot after all the good parties. So thank you, everybody, for coming today. I really, truly appreciate it. Today we're going to be looking at Maya 2015 and some of the improvements that were made to Extension 1. 2015 Extension 1 will be available for download in just about a month if you're on desktop subscription or maintenance subscription. So we're going to be using some of the assets that we developed internally, this Hyperspace Madness content, and we're going to be looking at lots of things that are kind of new in 2015, as well as some of the improvements that were made for the extension. So we're going to be doing things like checking out Viewport 2.0, playing around with some particles that are now newly supported in Viewport 2.0, looking at geodesic voxel binding, lots of improvements made to the way we handle color in our new linear color workflow. It's really, really pretty awesome. So I hope you guys enjoy it, and we're going to dive right in. So the first thing that we're going to be talking about really quickly are some improvements that were made that are sort of the nuts and bolts, things that you do every day inside of Maya, things like UV layout work. And this used to be a task that was always really quite tedious inside of Maya in most packages. And we've now got a new UV layout unwrapping tool that's really pretty amazing. So I'm going to walk you through that first. So we've got this scene, and we'll be talking about the rendering quality in it in just a second. This is all being done in Viewport 2.0, which is now the default render inside of Maya 2015. This is really cool because it brings the level of quality up, and it also improves the performance pretty significantly. So if you're on a relatively modern machine, anything within the last 3 years, you'll be able to implement Viewport 2.0. If you're on an old machine, like a legacy machine, it'll defer back to the legacy Viewport. But I'd imagine that most anyone in this room is running hardware that's current enough that you'll be able to take advantage of Viewport 2.0. So let's go ahead and bring up this first head, and what we've got here is I've got a piece of geometry that doesn't have any UVs assigned to it yet. So let's just go ahead and bring up our UV texture window, and I'll walk you through the process of adding some UVs onto this object. So this is something that you would traditionally do using something like a projection as your starting point, which is exactly what we're going to do in this example. So we're going to go ahead and just jump over to our poly tools, create UVs, and we'll just do a planar map of this down the x-axis. That's totally fine. So with that done, we now have UVs on here, and this is great, except if I was trying to paint on this in something like Mudbox or any 3D painting package, because these UVs are all stacked on top of each other from that process of being projected down the x-axis, it really isn't going to work very well, right? There would be overlapping objects and things like that. So what we want to do is we want to unfold that or unwrap that. So the first step in that process is going to be to define a simple edge to split its head from and unwrap it. So this is pretty standard workflows inside of Maya. I'd imagine that most of you in here are Maya users, so you can just grab an edge. Let's turn off that soft select really quickly and spin around to the back side of my head here, and I'll just hold down my Shift key and double click to add another edge there. So we've done a selection loop between those edges, and we're just going to go ahead and break those guys and turn on our border edges so that you can see we've now got a nice spot that we can use to unwrap and unfold our head from. So this is really, every couple years there's a magic button inside of Maya. For 2015 we have a few of them. The unwrap algorithm now is ridiculously good. Excuse me. So let's go ahead and just do a quick unfold. So if we jump up to our polygon menus one more time and tell it to unfold this guy, what it's going to do is it's going to go through and it's going to unwrap it. And there's a couple areas I want to draw your attention to. And these are the things that it does that are actually really pretty awesome. Areas like in the eyes. This is an area traditionally where there was kind of an undercut happening in that eye, so you'd have a little bit of overlap on top of those guys. The unfold does a great job inside of that area. Also the corners of the mouths. These are areas that unfold tools traditionally are going to have a hard time, and you can see that with this new algorithm, it just looks right. It just works right out of the box, and that's pretty awesome. Another thing that's kind of nice about this is it has the ability to show us where the stretched areas are and the compressed areas are with the new shader. So if we turn on our shading model here, you can see that we get a nice visual representation of where the compression and stretch is happening in this UV layout. And this is actually pretty good. The gradients are relatively smooth. If there was very sharp gradients in this, that would be identifying a problem. There's a little bit of distortion happening there, but it's really not that bad. The other thing that's kind of nice about this is there's been a ton of work put into the overall way we interact with the UV window. Traditionally, inside of Maya, the standard move, scale, rotate tools didn't work with UV selections in the UV window. It was a little weird feeling. Now it's the same tools that you have in your 3D viewports inside of your UV texture window. So this is a really nice advantage that we have now. So if I was to do something like grab some UVs on this guy and hold down my B key, you can see that I can get a soft select, so I can start to feather in that selection, soften it out. And if I start to play around with this, you can see as I change the UV layout, I get a real-time update of that shading model, again, showing me where my areas of distortion are. So it's worth mentioning that Maya in its viewport has the ability to work with, obviously, UVs. We can work with UV tiles also, both in Mudbox format and UDIM format. So if we go ahead and turn this on, this is another nice little new thing that we've added is the gradient shading. So if we turn on our gradient shading, let's just turn that guy off, turn on our tiles here, you get a really good representation of where U1 is, where V1 is, and the gradients are all labeled. So it's very simple to know if you are working in a multiple tile pipeline using something like Mari or Mudbox, having the gradients inside of Maya to help you quickly identify which objects or which tiles on which faces is really quite nice. And these are all these little subtle things that go into making Maya feel just more polished, more robust, and more complete. In 2015, how many people here are running 2015? Just curious. About half of you. It's a ridiculously good release. It was a really big release for us, and the improvements that we've made in the extension just further add to the benefit of the application. So I'm pretty. 2015 was fun. It was a good product to make demos with this time. So the next thing that I want to talk to you about really quickly is some improvements that we've made to binding. So this again is another one of those things that we keep looking at binding, right? It's something that you do all the time if you're working with characters. So a couple of releases ago, we came out with an algorithm called heat map binding. And the idea with that was it was trying to, if you have joints that are close to each other, those joints often will kind of cross over and get vertices from neighboring joints kind of bound into each other, and things like fingers in between legs and stuff like that would be kind of a hard area to bind. And the heat map algorithm was designed to help with that, except it was very specific in the type of geometry that it expected, right? It needed closed geometry, it needed quads, it didn't like n-gons, if it meets those criteria, heat map is super, right? It works really, really well. If it doesn't meet that criteria, it kind of falls apart. So we wanted to come up with a way of sort of getting the benefits of heat map, but with the flexibility of a traditional, just simple, smooth skin bind. So that's what we came up with, the Geodesic Voxel binding. So what this does, I'll just run the movie really quick before we jump into the tool. The Geodesic Voxel binding voxelizes the space around your character. Basically, all these independent meshes get voxelized. Then it finds where the bones are, and it does a mapping based on the voxelization of the surrounding mesh to the bones. So that gives us the advantage of being able to work with geometry that's basically a mess, right? It doesn't have to be good, clean geometry. It can be n-gons, it can have holes, it can be a whole bunch of different pieces. Because we're voxelizing the space and making the binding maps into that voxelized space, it doesn't matter what's underneath it. So it gives you kind of the advantages of a very flexible tool that's also very accurate. So let's go ahead and just look at an example of that. So I've got this piece of geometry in here. I've actually got a hierarchy of geometry. If we display our joints here, we'll just say show joints really quickly. Do I have my joints turned on? I probably do. There we go. All right, so let's just go ahead and select those joints. And let's jump out to our outliner here. And you'll notice that in our outliner, I've got a folder. And in this folder, I've got a whole bunch of pieces of geometry. So the meshes that we're looking at here are basically open-faced. They're actually clean geometry. They are all quads inside of this mesh. But the hierarchy is what's kind of cool about this. So we'll take that with our joint selection. We'll bring up our smooth bind options, and in our smooth bind options, what we're going to do is go ahead and just use selected joints. That's awesome, and Geodesic Voxel binding has been turned on, and we're setting the base resolution. So we'll go ahead and we'll hit apply on this guy. It'll take a second to go through and process this. So the base resolution is how fine is that voxelized space. The higher the resolution, the smaller the voxels, the longer it takes, the more accurate the mapping. Pretty straightforward, right? So with that done, we can go ahead and just jump in here and look at a couple of areas. Let's hide that UV guy right there. We'll grab this joint. Oh, come on, show joints. My mind is going. The list is long. So if we start to rotate this, you can see that it does a really nice job of preserving the volume in that crease. And also notice that obviously because we did this on a hierarchy, these are all going to be individual pieces of geometry inside of here. So really pretty cool workflow. So let's go ahead and kind of scrub through this time slider. I've got some animation on this guy already. And you can see that default binding actually did do a really nice job in areas around in between the legs. All the fingers are all weighted pretty nicely. You're always going to go back and further refine this, right? This is about getting you a good starting point, 80% of the way, 90% of the way. You're still going to want to go back there and use the traditional paint map tools to make those relationships to those bones be exactly what you want. But this gives us a really fast starting point. And for some things, it may be good enough. I'm going to go ahead and jump over to a version of this character that's had a little bit of paint work done to it, so you can see it's slightly more refined so that we can move forward with our presentation. So let's go ahead and not show those joints anymore. We don't need to see those guys. So the next thing that we want to talk about really quickly is Viewport 2.0. So Viewport 2.0, as I mentioned previously, is now the default viewport inside of Maya 2015. What this is going to do is it's going to allow you to raise the visual quality of your scenes when you're interacting with the objects. It does things that are really pretty cool, like hardware shadows, soft depth map shadows very, very quickly, screen-based ambient occlusion, hardware-based anti-aliasing, all the things that you'd kind of expect maybe in a game engine, we now have the ability to do inside of the viewport. And we're going to be talking about a few of those in detail just in a second. So what we've got here is the ability to take our viewport and also accelerate it in the form of vertex caching, which is a very powerful feature. If we go ahead and bring up the options for this, I'm going to turn on the vertex animation and put it to hardware. So by putting it to hardware, what I'm basically doing is I'm evaluating all the meshes in the scene, all the deforming meshes in the scene, taking those vertex points and dumping them onto the GPU. So the first time we play through this, the performance will be pretty good. We'll probably be around, well, let's say, 15, 20 frames a second, 15, 12 frames a second. And you can see as soon as that's done playing through, it just jumped up to 30 frames per second, which is a pretty significant speed improvement. That's because we're no longer evaluating all those deformations. It's just dumping it off the GPU. And we're actually running on a HP workstation here. It's got a NVIDIA K5200, the new card that they just announced at the show. So it's a really nice computer. I'm actually also using a Fusion IO card. It's a pretty great computer. But even on a laptop, like an HP laptop, if you have a pretty decent video card in there, this stuff is going to fly. It's very, very fast. So the next thing that I want to talk about really quickly is just some of the things that Viewport 2.0 brings to the table as far as the visual quality of the scene. So obviously, as we're scrubbing through this, you can see that there's hardware shadows in the scene. I've got high dynamic range images loaded in here. We're going to talk about the color management aspect of it a little bit later. But we also have screen-based ambient occlusion turned on. So if I go in here and I turn something like that off, you can see that we lose a little bit of those cracks and grounding, things like that. We've got hardware-based anti-aliasing also turned on. So all of these little things go into making this rich visual feel to our scene. The other thing that Viewport 2.0 does that's kind of cool is it has the ability to really work with the shaders, right? So if you're used to building shaders up that a software render could handle and doing things with all the utility nodes, the math nodes, some of the sampler info nodes or the facing ratio nodes, we have the ability to evaluate all that and actually have them show up in Viewport 2.0. And I'm doing some of those sort of traditional software tricks on the Earth here. So if we zoom out at this Earth, you can see that it's got this kind of glowing ring thing happening. The way I'm doing that actually is just with a series of ramps. If we go ahead and make the world selectable here, you'll see that that glow ring is actually, it's a pretty large sphere. All that really is, if I kind of pull that out there, is a piece of geometry that's got a shader associated with. So if we graph this guy, I'm doing, I'm pumping some ramps into incandescence based on the U and the V of it. And then I'm taking something like this sampler info node, and I'm grabbing the facing ratio, and I'm piping that into all of these different little maps for ambient and transparency. So it's basically, if the normals are facing away from the camera, it's popping that glow. If they're facing toward the camera, it's turning it off. And this is something, again, that software renderers have always been able to do. Now that we can do that in hardware, it allows you to do some really great pre-visualization work. Or, if, for certain things, Viewport 2.0 might be good enough, right? And you can always take Viewport 2.0 and use our batch render. We call it hardware renderer version 2, I think, in our render window. Let me just pull this up here. Yeah, we call it Maya Hardware 2.0. That basically is the Viewport 2.0 renderer. So if you switch your render options in your render settings to Hardware Render 2.0, it's just going to use the GPU to crank that out. You can launch it in batch. And all of this now is in full float. So you can take your hardware renders out of Maya's Viewport or Viewport 2.0 as a full float EXR file. That's newly supported in the extension. So it actually is pretty sweet. So another thing, check this out. What I'm doing here is, if you look at my clouds, I've actually got some volume to them, which I think is pretty slick. I took a bunch of spheres, and I basically, let's just hide that really fast. I'll show you what I've done here. So I've got a bunch of utility nodes inside of here. What I did is I took the We've got a little facing ratio thing, pumping some ambient into the edge of it to give it that slight glow. And then I'm using these HSV ramps to essentially clamp down the transparency. So I'm changing the transparency. All I did is took like 6 spheres and offset them a tiny little bit. And then on each one of those, I just offset the alpha channel a little bit and kind of erode it. And that gives those clouds that sort of slightly volumetric feel, which, I don't know, I think it's cool. You guys don't think it's as cool as me. I was pretty happy about that. It's like, that's pretty cool. All right, so let's just keep moving forward. And it's worth mentioning that these maps on the clouds here, these were painted in Mari. So these are UDEM maps that come in through the multi-tiles. I'm not going to show that. It's kind of pretty straightforward, but that's what's going on with those guys. So the next thing that we want to talk about with Viewport 2.0 is the support for the dynamics. The reason we were able to make Viewport 2.0 the default engine for our viewports now is because it supports pretty much everything now. It supports the particle systems, it supports in-hair, it supports projection shaders. That was new in 2015, including camera projection. So if you're trying to do some set recreation or some projection mapping, the fact that those are supported in Viewport 2.0 and they're ridiculously fast it's really, really cool. So what we're going to be looking at next is just a quick particle workflow. I want to spend a little bit of time diving into some of the things that Viewport 2.0 can do that previously you would have to actually commit to a software vendor to see. So I think I've got a bookmark saved here. Get back to my T-pose here. So I've got this ship, and what we're going to do is we're going to put some particles in here. So if we go ahead and turn on first let's set some animation up on this guy, right? Let's just kind of do something like, push it back, maybe get it so it's not hitting that dude. So we'll just set a keyframe on that. Notice that the keyframes, we've changed in our channel box and our attribute editor the color coding. So when I have an active key, it's dark red. As soon as I, oops, let's undo that. Let's go back here and get back to frame 1000. So we'll just key that dude. Kind of pull forward in time here. Key that guy one more time. So notice that the color coding changes. So if I'm on an active key, it's bright. If I'm off of it, but that channel is animated, it goes to a light red. If you hover over top of these, tooltips comes up and it tells you what the value is and what the attribute's actually filtering into it or feeding it. If you jump back to the attribute editor, all that color coding information comes across in the attribute editor also. So these are a couple of little things. These are all extension 1, kind of that little polish that we talked about that were added into extension 1. And there's a ton of stuff like that throughout the extension. I think there's 37 improvements in extension 1. The big one being the color management, but lots of little stuff like this keyframing coding that's happening there. Oh, and it's also worth mentioning that if you take an attribute like that guy and you start to modify it, it'll give you a visual representation that there's currently an active key here, but you've done a tweak to it. You want to commit it into it by hitting the S key or the Shift W key or not. So it's constantly kind of giving you these little visual cues. And you can also see the scene here. We're working with about 1.5 million polys, so it's not. This is a pretty typical scene, right? It's not that small. And the other thing that's pretty interesting about this is OpenSubdiv came out in Maya 2015, and what it does is we've always had the ability to do subdivisions inside of Maya using traditional count, mill, Clark. With OpenSubdiv, it gives us the ability to take objects that were creased, and this object actually had a ton of creasing done to him. If we grab him and look at him really quickly, let's go ahead and I think he's the Sven Voxelbein guy. Let's grab this guy. So if you look at this character, you'll see that he's got all these hard creases. So the hard creases previously inside of Maya with traditional count, mill, Clark, the frame rate would really slow down. And you saw that we were still hitting 30 frames per second, even though this guy's been subdivided. So it's really pretty awesome. And it's worth mentioning that in our character, the smoothing now in extension 1 also has the ability to use an adaptive algorithm if you wanted to. So the adaptive algorithm, unfortunately, currently isn't supported in Viewport 2.0. So if you switch to adaptive, you have to jump back into Viewport 1 to see it happen. But that adaptive algorithm was something that was there before. We just kind of hit it, and now we've decided to expose it. So check it out if you're trying to do something that's maybe changing in size a good bit or changing in depth a good bit. That adaptive algorithm sometimes has some advantages. So let's jump back into the particle stuff really quickly. Let's get our ship kind of moving through here. We'll turn our particle system on, and we'll hit playback on this guy. So what we're looking at are obviously some in particles in our scene. I've got these in particles set up to render out using just standard spheres. So all the different particle types are supported inside of Viewport 2.0. So what I'm going to do is I'm going to just jump over to, let's jump over to Sprites. So with Sprites, obviously, we have the ability to load images onto these cards, right? Right now, these Sprites don't have anything mapped to them. It's just got a standard Lambert material on them. And you'll notice that when we jumped to Sprites, the size isn't getting that radius set based on the age like the spheres were. So the first thing I want to do is address that, right? So inside of Maya, if you haven't used the particle system, the in-particle system before, it's very similar to the traditional particles inside of Maya. You add attributes to things, right? So particles don't really have a radius. They have an X and a Y size. So what I want to do is I want to take and hijack this ramp, which used to be driving the radius. So if we jump in here to our guy's particle size, right? There is a radius mechanism that's built in that the software renderer particles would use, the cloud particles would use, the sphere particles would use, but Sprites aren't really hooked into that. So the first thing we want to do is just hijack that and make that drive the radius of our cards that are ultimately going to hold a little fractal image to make our Sprites. So this is something that's really fast and easy to do inside of Maya. If we just graph the inputs on this particle system, all we're going to do is we're going to take this particle system and I'm going to drag it onto itself to bring up the connection editor. It doesn't matter what I hit. Oops, let's not do that. And I'm going to grab that internal ramp. So you can see that there's all these internal things that are internal ramp radius. And I'm just going to jump down here. I've already added on the per particle rule for Sprite X and Sprite Y. So by doing that, now you can see that our radius is driving those particle shapes. So it's just a simple, quick little trick. Instead of using an array mapper to do that, I just hijacked it back into that radius. So the next thing that we're going to do is we're going to go ahead and take these guys and we're going to graph the material that's associated with them, and we're going to start building up a slight shading network. And this, again, is something that Viewport 2.0 can do that previously you'd have to be doing a software renderer to get this kind of feedback and see exactly what type of shading engine you're going to do. So what we're going to do is obviously just on this guy, double-click on it, map to it a fractal. So we'll just grab a standard Maya fractal. It's mapped to the transparency, right? So there's our fractal breaking that up, but it's still sort of in the shape of a square, right? So what we want to do is we want to first, what we're going to do is make these guys change their opacity based on their age, like those, we want them to kind of fall off and taper off. So we're going to use the sampler, the particle sampler info node to do that. So let's just go ahead and graph the inputs to this guy. And if you hit your tab key inside of Maya in the node editor came out a couple releases ago. There's been some more improvements made for 2015. It allows me to start making something. So if we start to write particle, so if we go down here, there should be a sampler, a particle sampler info. So we'll grab that guy. And if we hit our 2 key or our 3 key, you can see that we can start to expand this out. So normalized age is what we're going to grab to that guy. And we're going to shove it into this fractal, into its color offset to start to make those guys become more transparent. You can see as I start to increase that color offset, they start to become transparent. We want that tied, that color offset, based on the age. So instead of just piping it in there straight through the age, I'm going to send it through a ramp. It's always a good idea to use ramps inside of Maya to sort of give you a nice mechanism for manipulating the range of the data. It takes a linear, a normalized range and lets you use the ramp widgets to modify that. So let's go ahead and create a ramp in here really quickly. We'll just type ramp, and we'll set this to a texture. So by default, if you look at a ramp, it's set to be a V ramp. So that's the attribute that we want to shove the age into. So if we jump into this guy and we hit 4, we get a big, long list of this, right? And you could use the filter to filter out and say, only show me things with Vs. What I'm going to do is I'm going to change what the 4 key displays to me, because when I work with ramps, I hit stuff into the V chord almost every single day. So I'm going to make it so that that's really the main thing that shows up when I hit my 4 key. And this is really easy to do inside of Maya by, excuse me, just saying, edit the customizable list for this guy. So if we do that, and we kind of scroll down here and go to V chord, UV chord, we'll just grab that V chord is what we're going to show. So now if we hit 1, 2, or 4, let's go ahead and just, did I get that in there? V chord. There you go. So now we can turn off the edit customizable list, right? And now, so V chord, every time I go to create a ramp now, that V chord is going to be exposed to me. I don't know why it's not just exposed by default, but there's a tip for you. Make it exposed because you're going to use it a lot, right? So we're going to take that V chord and we'll grab the edge, shove that guy into, come on. Shove that guy into there, and then we're just going to take this ramp and put it into the color offset. So now you can see as I modify this ramp, right, I can adjust where those particles are going. Oops, let's put that back to black. I can adjust where those particles are going to, basically disappear with the transparency. So the next thing that we want to do with this really quickly is I don't want it to just be a simple square. I want to clamp that down. So we're going to use another ramp to do that. We'll just type ramp one more time. Or I could just take this guy and do Control D. That would be even faster than typing ramp. So with that guy, what we're going to do is we're going to take the output of this, and we're going to shove that into the color offset. So this ramp has that color balance also. So we're going to take that and just shove it into the color offset, and then make this become our transparency. So now, if we go back to this ramp, I'm going to switch its type from just being a linear ramp or a V ramp to a circular ramp. So by doing that, I've now got this little circle shape that I can use, again, using this ramp to adjust it to sort of clamp that down into a nice, simple little circle. So the ability to have all this stuff evaluate in the viewport, show up, and let you prototype the way your sprite-based particles are going to look using sampler info and ramps is really powerful. And this is something that was newly supported in 2015 of Maya. You guys like that? No clap? Come on. I think it's cool. I don't know. All right, so the next thing that we're going to talk about really quickly is the color management that's new in 2015. So we've had color management inside of Maya. It was a joke, right? It didn't work right. It was SIGGRAPH 2009 when it came out. That was one of the worst years of my life. That was such a hard show. And we've been living with bad workflows in color management since then. And everyone's kind of developed their own sort of hacks to work around it. We now have an amazing color management story with Maya. It's based on the same technology, it's a shared technology component across several Autodesk products. So the color management that's in flame, luster, smoke, the most amazing color management tools in the world, that SendColor, that technology component's now directly inside of Maya. So what this does is it gives us a very flexible system to manage color completely through the pipeline of Maya and your facility. So it'll work with other standards. So if you don't want to use the SendColor, you can use OpenColor IO with it. It works completely with ACES. So if you've already got a color pipeline established using OpenColor IO, if you have a color scientist on house that's developed something for that, you can load those OpenColor IO lookups directly into Maya. So let me just walk you through that process really quickly here. So, and it handles dealing with legacy files really elegantly too. You'll find when you open your legacy scene files, the intelligence that it has built in to handle that is really pretty awesome. So in color management, what we have here is I've got it turned on, and the way it works is through a series of color transforms. So essentially what you're doing is you're going to figure out, well, what's my main texture map in my scene? Is it sRGB? Probably, right? So that's the first thing you define is what your viewer, what your main default color space is going to be. You take all those images and you transform them into your rendering color space. That's the first transform that happens. And you can choose from a list of transforms for your render space. These are all linear in color transforms. The difference is going to be the gamut that they support and the color primaries that they're based on, right? So for this traditional linear color workflow, which is the way it's configured out of the box, would be a kind of standard CG color workflow, we're just going to leave it at Rec 709 and sRGB. They use the same color primaries. It's the same gamut. Notice again that we can, if we wanted to work with ACES, we could work with ACES. And if we wanted to work with OpenColor IO, essentially what you do is you load the OpenColor IO config, and then all these color transforms change to have the lists that the color scientist has locked down in your pipeline. So OpenColor IO is really great, but it takes a scientist to make it happen. Or you need to get some OpenColor IO config files. Maybe if you're working with a larger vendor, or if you are a large vendor, you're subbing it out to smaller shops, you can share that OpenIO config file, and the choices are essentially limited. The thing that's nice about the SendColor is it's easy for a small shop to have this color management happen, and it's easy for an artist to change the way it works and reconfigure it. So that's really the advantage of the shared technology component that we have with the Flame. And we're going to look at that just in a second here, because what I want to do is we've transferred our default images into our render space, so we're rendering everything in linear. The next thing that we want to do, because we don't really want to work and look at linear images in our viewer or our renders, we want to at least put another color transform on those when we're viewing them and working with them to get them to something that represents the final output, right? So that's sort of the last lookup that we're going to do. So that would be then the view transform. So right now it's set to sRGB. At any time, you can add new view transforms in here. So what I'm going to do is I'm going to say add new, and we'll just give it, we'll browse out here, and we'll jump to my send color here. So it can load traditional, old school 3D LUTs, or it can load .ctf files, which are essentially files that are saved out of our creative finishing tools using send color. So it's a send color file. What that means is if you've brought some linear images, say you've got guys working, doing the finishing while you're working, they're polishing shots. If they've done some grading or some tone mapping using any of the grading or coloring tools inside of a flame or a luster or a smoke, they can save that out. That, what they're taking the linear color space and making it look the feel they want, save that out as a .ctf file, and then you can use that same lookup in Maya, in both our viewer and our render view, so you can work in context to what the grader's done, which is really pretty sweet. So we're going to jump in here and grab this flame tone map, and we'll just grab the photo map blue, and we'll open that guy. This is the color space that this was done in. It was raw, so we'll just call it blue. And we'll save that out. And as soon as I save it, you can see that my background there just switched a little bit. So we'll close this down. So what we've got here in our viewport is fully color managed. Right now we're viewing with the transform on. So if we start to increase the contrast in this guy a little bit here, you can see that this is full float. So everything in Maya is full float. If we clamp this down, this is a high dynamic range image in the background. Obviously, if we overblow that or overexpose that, areas of shadow show up correctly. If we wanted to switch this back to the default sRGB, we could. Here's the thing that's kind of cool. If we go into this blue or maybe even this sepia lookup, which is kind of weird for space to have a sepia lookup, but it was someone passed it on to me. Color management also is managing our shader pots. So all the color pickers and the shader pots are also being color managed. So let's just look at a quick example of that color management. And we'll go ahead and grab a simple polygon object. So with that polygon object selected, this has got the default material on it. So that's just a default gray. You look at the slider value, it's 50% gray. What we're going to do is we're going to go ahead and just switch this over to show manage color pots. So as soon as I do that, you can see that 50% gray, the slider is actually way over here on the right-hand side because, again, it's letting me pick and choose colors where what I'm visually seeing is going to give me the actual color that I'm going to get, and the numerical values and where they are on the sliders are going to be in that render space. So it's a really nice way of working because it's sort of what you see is what you get. And this is also true. Excuse me, I'm losing my voice here a little bit. Let's jump back to the sRGB lookup. It looks a little bit better. And just crank this guy out here. Let's say I wanted to match the blue on this ship to that shader ball. If we jump into our color picker, you'll notice that the values that I'm on represented as the RGB values, they're really small numbers, right, because we're working in float. But you can see that the blue number is really quite high. Even though the swatch is showing me I'm picking the white pixel, it's telling me in the RGB values what the underlying actual color is in its render space, right, in the linear space. So if we click on this guy, even though it looks like we're picking white, we really are picking those RGB values underneath it all. So the color management works throughout the whole pipeline, both in our interactive views, our shader pots, our color picker, our render view window. So that's all pretty awesome. So the last thing that we're going to talk about really quickly is XGen. Let's just zero this guy out. We're not going to be talking about Bifrost today. It would have been weird to do water and space, so we're just going to finish off with XGen. So we've got our character here. Let's go ahead and turn off our hair. And XGen, for those of you who haven't used it, is an arbitrary instancer. So it's great for doing environmental set dressing as well as doing hair and fur effects. It's really, really cool technology. It came from Disney. It's been used in a ton of feature films, and it continues to get better every release. So there was some nice improvements made to it in 2015, and there was also some really nice improvements made to it in the extension, in the ability to work with standard shaders and ramps with it. So we're going to look at that really, really quickly. So if we generate our hair really quickly, what it's doing is it's going through and it's using guides to place the main kind of area where the hair is, and then it fills it in with all of these arbitrary instance pieces of geometry. So let's just select those guys and frame in on this a little bit easier. So all that hair is being filled in, and I'll turn off the helmet too because it's kind of hard to see through the helmet here. There we go. Oop, go away. So let's jump back to the XGen window and jump over to our top spike. So the way it works is you have a collection. The collection might be, my character's Finn. On him, I'm going to have different descriptions for his eyebrows, his hair, some stray hair, some nap fill. So that's what we're looking at right here. I'm just going to jump over to the top spikes, which is going to give me the ability to start interacting with these main pieces of hair here. So if we look at these guys, we've got these guides, and these guides are essentially what are controlling the overall position of those hairs. If I go and I select some control points on those guides, let's go grab those guys right there and hit into our W key. Oop, come on. Might be hosed on me here a little bit. Let's grab those guys. It's not working. We'll keep moving forward here. So the guides basically control the overall shape. Then layered on top of those guides are the ability to add modifiers. So what modifiers do is they allow you to break it up. There's a whole list of modifiers, and they're pretty awesome, right? They're very, very flexible. And the beautiful thing about the modifiers is they have the ability to work with expressions and maps, and you can combine expressions and maps together to really add a lot of flexibility to this. So what we'll do is we'll just put something on here that's pretty easy to see, something like noise. We'll go ahead and we'll say OK on that guy. And with that noise on there, we'll hit our preview one more time. I'm going to have it preview just my current description. You'll see that the noise is going to go through and basically fry those guys. There's a ramp that's adjusting it down the length of the hair. We'll put that down to something like 0.1. So that's really what you're doing with XGen in a groom, right? You're taking hair, you're using guides to get your overall shape, and then you're laying modifiers on top of that to give that subtle detail or that fine detail. So we now have the ability to have standard materials applied to the hair and use XGen PTEX lookup tables to actually make that stuff render. So let's go ahead and look at a quick example of that because I only have about 3 more minutes here. So we'll go and we'll create a new material. Let's just jump back here and create something that would be good for hair. So we'll do Maya surface. We'll grab that guy. And we'll select our hair really quickly. And I'll assign that material to our hair. So what we've got now is we've got a Maya material assigned to this guy. And what I want to do is I want to texture map this. So previously you couldn't really, prior to extension 1, you couldn't really texture map this in an easy way. There was ways of doing it, but it was involved a little bit of expressions. It was just not as elegant as it needed to be. So we now have the ability to do some pretty cool stuff. I'm going to walk you through that really quickly. What we're going to do in this example is we're going to map to this guy using some new XGen lookups. So if we just do mental ray, XGen lookup, I'm going to grab one called PTEX lookup. That's going to let me load a map, and I'm going to grab one called hair length mapping. So with hair length mapping, what I can do is I can use this to shove into a ramp. Again, using ramps. We talked about ramps before and how much I like using ramps. So let's create that ramp. So what we're going to do is we're going to take this ramp, and we're going to have this ramp essentially drive the color of the hair down the length of it. So if we hit our 4 key on our ramp, come on. Oops, I don't want to hit my 4 key in there. Let's hit 6 and 7. Let's get back to that. You can see that V chord's there again, right? We talked about always using the V chord. So now what we've got is we've got a ramp going down the length of the hair. So if we render this, come on. I'm going to render it all at one time because I only have 2 minutes left. So what we want to do is instead of just having it be black on the bottom, on the roots, I'm going to use the PTEX lookup to load in a PTEX file. It's just like, I think it's red and black stripes. I just did something really, really easily recognizable. So what we're going to do is we're going to say, you know what, wherever that black is, use this PTEX file. So this is really cool because you can actually start to stack up different PTEX files down the length of the hair, right? So it's almost like 3D mapping in a sense. Really pretty cool. So this will render off here. Again, the render view is going to be fully color managed in 2015 Extension 1. So that same set of color transforms that we have the ability to look at in our viewer are also going to show up inside of our render view here. So off it goes. So we've got black and red on the roots, or on the roots, and then we're transitioning to white on the tip. So if you wanted to do something like, tiger fur that's got snow on top of it or something like that, you put the tiger fur in the root, you give a little bit of tinting to the tips, maybe a little bit of noise in that tinting map in the tips. Really, really nice new feature inside of 2015. And let's just switch this over to this guy. Again, everything is in full float inside of Maya. And if we wanted to see the linear color space, you can just turn off that color transform. So that's what it looks like in the actual rendering color space that we've defined without any tone mapping or any color lookups added. So thank you so much for taking the time to look at Maya 2015. I know it's the first session after all the big parties. I'm sure lots of people here are hurting like I was hurting yesterday. Oh my. Today I'm doing much better. So thank you again. Extension 1 of 2015 will be available in just about a month for Maya users if you're on desktop subscription or maintenance subscription. That's it, everybody. Cheers.